This is a quick walkthrough of question 3 of the particle model questions set last week. So if we look at this question, this is question 3. And as we can see with question 3, it's about specific heat capacity. So this should be familiar to you. This apparatus should be saying to you specific heat capacity. If not, let me know and I will go through that with you individually or as a group. Okay, so energy is transferred through the copper block using the immersion heater. What is the name of the process by which the energy is transferred? 3 to choose from here. Hopefully the one you arrived at was conduction, and you would know why convection and radiation aren't the ones used in this case. If not, let me know. Right, so we're looking at figure 2 here to determine how much energy was needed to increase the temperature of the copper block by 35 degrees Celsius, getting our answer in joules. So if we look at the diagram here, we go up to 35 on the y-axis, draw a line across. When it hits the line from that point, we draw a line down, and we will see that, and this is what they would want you to be doing on the examination paper. They would want to be seeing this. And then if we zoom in on what we can see going on there, 30,000, 1, 2, 3, 4, 5, each one being 5. If there's 10 in total, that's 35,000 joules as the answer there. The next question, part C, looks at the copper block having a mass of 2 kilograms. If we've got the mass of the block and we've got our equation for the specific heat capacity and other values, we can calculate the specific heat capacity. So here is our equation. All the steps I've put through there. Always make sure they're in the correct units. So that's what we're going to do now as we attempt the question. So if we now look at the equation only, okay, the change in thermal energy is equal to the mass times the specific heat capacity times the change in temperature. The values that we have from that, from the graph, we have 35,000 joules, we have a mass of 2 kilograms, and we have a temperature change of 35 degrees. So we need to rearrange that equation. So in order to get the specific heat capacity, energy divided by the mass times the change in temperature. And if we work that through, it becomes 35,000 divided by 70. If you stick that into your calculator, or hopefully you can do that mentally, you should get 500. Now the units for specific heat capacity, as shown on the previous slide, are joules per kilogram degree Celsius, written as it is there. So that is the worked through answer to that one. Part D. The experiment does not give the correct value for the specific heat capacity. Suggest one reason why. Well, the first thing we need to think about is that value going to be higher or lower? Now, the value is likely to be higher. And the reason is that energy is going to be lost to the surroundings. And also energy is going to need to be used to warm up the heater at the start of the experiment. Either one of those would get you the mark. Okay, you could talk about insulation not being on the copper block. That would also get you a mark. But you would, any answers that are talking about human error or poor results or defective equipment in this instance aren't going to get you the mark. So it's making sure, if you're asked a question like that, the answer they're looking for is that idea of energy being lost to the surroundings or energy being used in heating up the heater. Okay, that concludes the go through of this question.